Acid-base theory. Let's start by talking about how to use curved arrows in the process of explaining reactivity in organic chemistry. If you recall from our first lecture where we discussed the idea of the HOMO and the LUMO as molecular orbitals that can allow us to tell what's going to happen, you can start looking at molecules like the alcohol shown here on the left side and the alkyl halide shown here right next to it. And the idea right here is that the carbon-chlorine bond, which is a polar bond, made up of a halogen, can create a low-energy LUMO, which has no electrons. On the other hand, the alcohol has lone pairs that can behave as the HOMO, and the attack always takes place from the HOMO onto the LUMO, right? So specifically, you would attack the atom that has the lower electronegativity between the LUMO, between the carbon and chlorine. So you attack the carbon, and the chlorine has to leave so that you don't violate the octet rule for that particular carbon. And what this kind of allows you to predict is that you form a new oxygen-carbon bond. The chlorine is no longer bound to anything. And this is not to be confused with resonance structures, because you are forming bonds where there used to be no bonds whatsoever, and you are breaking bonds where there used to be bonds, right? So this is not a resonance structure, this is an actual reaction. Now, the second thing that I want to point out is that the tail of the arrow always starts at electrons. In this case, the electron source is a lone pair, but it could have been a bond. You could start from a bond or you could start from a lone pair. It kind of depends on which molecules you have present. But the head of the arrow has to end up at an atom. It has to end up exactly at the carbon. If you don't draw the head of the arrow onto a carbon when you're doing this type of mechanisms, you will get marked down for that. So get in the habit of starting at electrons, ending up at atoms. Alright, so the second thing about it too is that when you form new bonds, the charges are gonna change. The oxygen used to be neutral, but it kind of gave its electrons to the carbon to form the new bond. And because it gave its electrons, it lost negative charge. So now the oxygen is positive. It's 1 unit more positive than it used to be. The chlorine, on the other hand, it accepted electrons from that entire bond. And so now it has more electrons than it used to be, and its charge goes down by 1 unit. All right, now, assessing what's going on with these two molecules is kind of interesting, because the oxygen here with a positive charge, known as an oxonium ion, makes it such that the hydrogen here becomes rather electron deficient. And the reason why is because not only is oxygen electronegative, a lot more electronegative than hydrogen, but now with that positive charge, it's withdrawing electrons towards itself a lot more than in your typical alcohol. So what we have right here now is a picture in which the chloride, which is full of lone pairs, can behave as the HOMO. And the OH bond with the oxygen bearing that positive charge now becomes the LUMO. And once again, the attack of the electrons will happen onto the atom that is least electronegative. So between oxygen and hydrogen, hydrogen is the least electronegative element, so that's where the electrons attack. And once again, so that you don't violate any of the electron rules, right? The hydrogen ion only has one available orbital, so you can only accept 2 electrons, and in doing so it has to give away the previous 2 electrons that it had, which ultimately end up on the oxygen. Now, when that happens, you have broken that OH bond. In the process, the 2 electrons that were part of that bond are now exclusively on the oxygen. So the oxygen now has more electrons than it used to have, so its charge goes down by 1 unit. So it goes from +1 to 0. And the chloride is giving its electrons away to form the HCl bond, and in doing so, its charge goes up by 1 unit from -1 to 0. So this is what we call a mechanism in organic chemistry. And from the point of view of frontier orbitals, you can kind of see what has to happen. And I'm not saying that you have to draw the orbitals, but you should start seeing the bonds as being potential LUMOS, lone pairs, and maybe even other bonds behaving as potential HOMOs. And you should be able to draw these arrows starting from the electrons and ending on the atoms every single time. It'll take a little practice, but hopefully this will help you out in the process of doing that. Alright, so just remember, HOMOs will always attack the LUMOS or SOMOS, where the SOMO is an orbital that has only one electron, so you can accept an additional one. We'll talk about that in the context of radicals later down the course. Okay, so that's it for curved arrows. In the next video, we'll talk about the Bronsted-Lowry acetone bases.